All right, you guys, so I'm actually going to go ahead and go over a few problems on the final for math analysis in this case. So to start off, I actually want to go ahead and start off with example or problem number 1 in this case, where we're actually going to go ahead and subtract the rational expression. And once we're done with that, we need to simplify, both numerators and denominators, and also identify the domain. So to start off in this case, guys, this expression here is being subtracted, right? Any expression that is either being added or subtracted, we have to have the same denominator in order for us to actually combine them. If we take a look at our denominators, they're actually not the same, right? So we actually have to find an LCD, right? We have to find an LCD. And LCD in this case actually talks about the least common denominator, which in this case would be basically factoring each of the denominators in this case, and then determining what's missing or what both of them could have in this case. So let's go ahead and actually factor the first one here. So we want to go ahead and factor the x squared plus an 8x plus 16, right? And if we do the diamond method in this case, that would actually give us x plus 4 times x plus 4. Once again, if you guys were to do the diamond method once again, we have a 16 on top and 8 on the bottom, two numbers that multiply to the top and add to the bottom would be 4 and 4. So those would be our factors. Moving on to the next one in this case, we want to go ahead and factor, in this case, the x squared plus a 4x. On this one, although this is a binomial and it's being the highest exponent is 2, I really can't use the diamond method on this one. So on this one, I'll just factor out a GCF, and that would actually be the factored form of both of these. Now, if you notice, this expression has x plus 4 times x plus 4 twice, and this one has x times x plus 4. So for them to be the same, I actually need my LCD to contain an x, because their bottom, this one here, has an x, and it also needs to contain two x plus 4s. So it has to contain both of them. All right, so that is the LCD. This isn't our final answer, but this is what we want to go ahead and get in this section here, okay? So because that's what we want to go ahead and get in each of the sections, let me actually rewrite this, but now factored. We have an 8x over x plus 4 times x plus 4. Once again, that is already factored, minus a 6 times x and x plus 4. Right? So from there, in order for us to get the LCD, I have to multiply this one here by an x, because that's what it's missing. So multiply this by an x, and I do have to do that on top and bottom. And on this side, I have to multiply by x plus 4 and x plus 4, because that's what's missing. Multiply. So then in this case, the denominator should actually be the LCD, x times x plus 4 times x plus 4. And in this case on top, x times 8x is 8x squared. And then this is actually a negative 6. So that's actually negative 6 times an x, and then negative 6 times a 4. So negative 6 times an x is a negative 6x, and then negative 6 times a positive 4 is a negative 24. And in this case, for this one, guys, this would actually be the simplest form. I could actually try factoring this part again, but in this case, I would just be, doing more steps in this case. So we would actually be done there, because we really can't factor any further in terms of simplifying the expression. So that is the expression simplified. Now for the domain part. Domain in this case represents any values of x, in this case where x is undefined, or where x is defined. So x in this case is basically all real numbers. Real numbers where x cannot equal, so this is cannot equal a 0, and it cannot equal a negative 4, right? And how we obtain, in this case, this part here, how we obtain that is by making this bottom equal to 0. So if I do x equal to 0, and then we also have x plus 4 equal to 0, and once again, x plus 4 equal to 0, I'm not going to write it twice, but this is already what x equals, and this one we subtract 4 and subtract 4, so x is equal to negative 4. So if I input these values into the equation down here, it's going to give us a 0. And we don't want that. So in this case, that's why our domain is excluding those values. So it could be any of them, just not those two. So that's for number 1. That's number 1.